Hello, my name is Firdos, and I'll be today talking to you about the shape of molecules. Well, in our daily lives, we see many molecules surrounding us, like air, which contains oxygen, carbon dioxide, nitrogen, and then we have our water, which is a very important molecule because all the life revolves around the water. We need to understand that these molecules are having fixed shapes and they have a specific geometry, which is important for them to be uh, understood. When we talk about the shapes of molecules, it's very hard to comprehend sometimes because it's in three dimensions and we cannot represent it easily on paper. Let's look at some of the molecules that we always struggle, and I've taken here some models to explain the concept. The first molecule that I have taken in front of you is the methane. In methane, there is a carbon in the center and four hydrogens surrounding it. So, this is your carbon surrounded by four hydrogen atoms. Thus, the formula of the molecule is CH4. What you have to understand that in this molecule, the two atoms are in one plane. If you look at it, it's in one plane, and in the second one is in another plane. It's like two planes bisecting each other. So this one is bisecting the second one. Now, let's talk about the geometry of the molecule. First, each bond is equally distributed. So the angle between two bonds in a molecule is around 109 degree and 28 minutes or 109.45 degrees. Then all the angles are same. So the angle everywhere has to be same in three dimension. So this molecule has a tetrahedral geometry. What do you mean by tetrahedral? So if you join this one with this one and this one with this one and this one with this one, you get one face, you get the second face from here, third face from here, and the fourth one beneath. So in all, we have four triangular faces. So this type of a figure is called as tetrahedron, and the geometry that is here is tetrahedral. Similar type of structure can be observed in case of CCl4. The only difference is that the hydrogen there is replaced by chlorine. If you look at it from all the sides, the molecule has same shape. So this is the shape of your methane molecule. Now let me look at another molecule, that is your ammonia. In the case of ammonia, if you look at it, there one of the carbon bonds with the hydrogen is replaced by an unshared pair of electrons. So this is your unshared pair of electrons that is replacing the bonds. Now we have a pair of electrons which is not distributed between the two atoms. It's focused only on the one atom, that is the nitrogen. So this tends to bring it closer to the central atom and thus making the force of repulsion more, as a result of which the bonds come closer to each other. Thus, what happens is that the bond angle is reduced. So, in this case, the bond angle is reduced to only 107 degrees. And the shape, if we look at the shape, please don't consider the lone pair or unshared pair of electrons in the bonding. So, if I remove this, look at the shape of the molecule. The shape of the molecule is very simple. It's a triangle, one side, then the second side, and the third side. So it's a triangular shape that's obtained. That's why it's like a pyramid, triangular pyramidal. Thus, ammonia molecule has a pyramidal shape. So the fundamental difference is that in case of methane, all the bonds are equally distributed and the shape is tetrahedral, whereas in case of ammonia, there are only three bonds and one unshared pair of electrons, which makes the bonds, nitrogen hydrogen bonds, to come closer to each other, and thus the angle that's here between the two NH and NH bonds is reduced to 107 degree. Thus, we come to a third molecule, which is your water. In the case of water, you have to understand that instead of one bond, two bonds are replaced by two unshared pair of electrons. So the two unshared pair of electrons are present in case of water. We have oxygen in the center and two hydrogen atoms. Here, these two unshared pair of electrons tend to focus more towards the oxygen, thus drawing it closer and thus repelling these structures, these nitrogen hydrogen structures, more strongly, and thus the angle is further reduced to 105 degree. And the shape is only, if you consider this shape, it will be like a V shape. If you look at the shape of the molecule, it's V shape. That's like a victory shape, angular, or we can say it's like an angular shape. So we have three molecules: methane, ammonia, and the last one is your water. In case of water, there is one more thing, is that because of the presence of oxygen and hydrogen, there is more focus on the oxygen, which tends to be more stronger than the hydrogen, and thus slightly smaller negative charge is developed here, and a slight positive charge is developed on the two hydrogen atoms. Whereas this thing is not observed in case of methane, because the carbon hydrogen bonds are having almost equivalent force of attraction. Now let me talk to you about another concept, that is the case of ethane molecule. When we look at the ethane molecule, as we see in the textbooks, we see that there are two carbon atoms, and these are surrounded by six hydrogen atoms. This is how it is. Now, if you look at these two atoms, they are all joined by single bonds, and thus they keep on rotating. It never happens that the molecules are at rest. They're always in the motion, moving slowly and slowly and slowly, because there's always kinetic energy available within the molecules. During this motion, you can tend to see that the molecules tend to align each other. When they align each other, that is eclipse configuration. In the eclipse configuration, the molecule has, you can see only one set of carbon and hydrogen atoms from one point, because the other one is hiding beneath the first one. This is the eclipse configuration in case of carbon. In case of ethane molecule, the another possibility is that if it moves slowly and slowly, the configuration tends to change, and thus the eclipse configuration is lost. Thank you very much for understanding, and this process keeps on repeating and repeating in case of ethane molecule, whereas this thing is not found in case of a double bond, because there is no motion between the two atoms. Thank you very much for your time. I hope you enjoyed my lesson.